A very good morning to all of you. Today we are going to look about jaundice. Okay, so I've divided it into two parts. So the first part I will be discussing how the RBCs are broken down and how these RBCs are, they are converted to bilirubin and what happens to the bilirubin and how it is processed in our body and how it is eliminated. Fine. In the next part we will discuss about each type of jaundice and what you actually see in those jaundice. Okay, fine. Moving into the topic, as we all know that there is a lifespan for all the objects. You name it, there is a lifespan. Okay, so RBC is no exception to that, right? So usually the lifespan of RBC is 120 days. Fine. So what happens once the 120 days, it has ended? The RBCs, it will not be able to squeeze through. Fine. So ultimately what happens, it is going to get stuck at one point. It is going to get stuck. Where it is going to stuck most often? It is going to get stuck in your, what is this? This, take for example, this is your spleen. Okay. So your RBCs, they are going to get destroyed in your spleen. Okay. Okay. Now in the spleen, you have something called as your macrophages, your splenic macrophages, your defense cells. This is your macrophages. Okay. Macrophage. And if you look at this macrophage, this is going to destroy my RBC, which is nothing but it is going to eliminate my RBC. Fine. So once my RBC reaches its lifespan, it comes down to the splenic macrophages. And if you look at the RBC, it has one membrane. Fine. It has a membrane, it has a protein, and it has a hemoglobin in it. This is the composition of RBC which you normally see. Okay. Now, what happens to this membrane? This membrane, it has some lipids. Fine. It has some lipids which is going to get converted into free fatty acids, and this is used by the macrophage for its own purpose. Okay. Now, at the same time, it has your proteins which are going to get converted into your amino acids. They are also used by the macrophages for its own purpose. And if you look at the protein, yes, it is going to get converted to your amino acids. And moving to the heme, your heme has heme part and a globin part. Fine. You also have some iron. Fine. So if you look at the heme, I'll talk about it later. If you look at the globin, yes, it is going to join your proteins and it is going to get converted to amino acids, and ultimately it is going to be used by the spleen macrophages for its own purpose. So if you look at the iron what you have in your hemoglobin, they bind to something called as apoferritin, and they are converted to your ferritin, which is ultimately going to convert into your hemosiderin. Fine. Hemosiderin. Okay. Excess amount of hemosiderin, we call it as hemosiderosis. If it causes damage to the tissues, we call it as hemochromatosis. Fine, you find the difference. Okay. Now, once this all the parts of hemoglobin we have discussed, and what is left now is your heme. Okay. This heme, if you see, it is first converted to biliverdin. Biliverdin with the help of an enzyme heme oxygenase. With the help of an enzyme heme oxygenase, this hemoglobin is going to get converted to biliverdin, and which is ultimately going to be converted to bilirubin. So this entire process is going to be happen in your splenic macrophages. Fine. Once your RBCs, it is going to get converted into your, it has a membrane, it has a protein part, it has a hemoglobin part, and all these are broken down, and finally you get what is called as your bilirubin. Okay. Your normal bilirubin will be around, if you look at the normal bilirubin, it will be around 0.3 to 1.2 mg per dl. Okay. So if I have 1.3, I can't tell the patient is having jaundice. If I have 1.8, I cannot tell the patient is jaundice. So what is the limit? If I have around 2.5 mg per dl, then I can call it as jaundice. Okay. Okay. Now, if you look at the jaundice, it is nothing but yellowish discoloration of your skin. We call it as jaundice. What happens if there is an yellow discoloration of my eyes? That we call it as icterus. What happens if there is a more amount of bilirubin in my brain? I call it as kernicterus. Very important term. Kernicterus. So kernicterus is basically your bilirubin in your brain. If you take an infants, they do not have that much developed blood-brain barrier. So what happens? Sometimes your bilirubin, if I'm taking some drugs, for example, sulfonamides, these sulfonamides will not allow the bilirubin to bind to the albumin, which I'll say what purpose it is used for. Once that doesn't take place, it can travel to the brain, and where it we call it as kernicterus. That's a very life-threatening situation. Okay, now we have got the bilirubin, and now it has to enter the blood so that it is somehow carried to the liver, where it is going to be eliminated. Okay, this bilirubin, if you see, it is lipid soluble. Okay, this bilirubin is usually lipid soluble. Okay, now this bilirubin is carried into the bloodstream. For example, this is your bilirubin. Okay, this bilirubin, if you see, they are usually very small substances, so that they can enter the microcirculation and they are easily excreted via your kidneys. Fine, so that should not happen. So what I'm doing, I'm secreting some proteins from my liver. Fine, that we call it as albumin. Fine, so this albumin, it goes and attaches to your bilirubin. This is a bilirubin trapping protein. Fine, so once this bilirubin is get trapped to my albumin, it will not be excreted via your kidney, because obviously it has a protein in it, and it cannot enter your microcirculations, because it has a larger size, it has become increased in size. So what happens, this albumin bound bilirubin is, once again, this carried to your liver. This is carried to your liver. Okay, now what happens in the liver? This albumin bound bilirubin is carried to my liver. Okay, and now before going into that, you should know what is this. This is my hepatocyte. Okay, you have these can be found in your liver, hepatocytes. So once it enters the hepatocyte, your albumin goes off and your bilirubin enters my hepatocyte. Okay, you have hepatocytes, the cells of your hepatocyte facing your sinusoids. This is your sinusoids, and you have your hepatocytes facing your biliary system. This is going to be your biliary system. I will explain everything. So once your bilirubin enters my hepatocyte, so just imagine that this is my hepatocyte. Okay, so once my bilirubin has entered the hepatocyte, what it does is, as I said, this bilirubin, if you see, it is usually lipid soluble. Fine, so I have to change it into water soluble. Fine, for that what I'm going to do is, I'm going to increase the concentration, or I'm going to increase the charge of it. That is, I'm making it more polar. So what happens, take for example, this is my bilirubin, and I'm going to add something to it to make it polar. What I'm adding is glucuronic acid with the help of an enzyme UDP glucuronyl transferase. So I'm adding glucuronic acid to this bilirubin to change it into your conjugated bilirubin. Fine, so this bilirubin, once it gets added by this glucuronic acid, it becomes conjugated bilirubin. Okay, now what the bilirubin before that, till it's conjugates, so that is from your spleen, it enters your hepatocyte, what is this bilirubin called? I am going to call it as unconjugated bilirubin, as simple as it is. Fine, so it is, this is going to be your unconjugated bilirubin, unconjugated, and this is going to be conjugated. Fine, okay, once it is conjugated, it becomes polar. It cannot enter out of the cell, because it is not now lipid soluble. It is becomes polar. It's water soluble. So what happens, with help of a specific transporter, fine, with help of a specific transporter here, this unconjugated bilirubin, this conjugated bilirubin, as you can see here, it comes out of your bloodstream. It comes out of your bloodstream. So what ultimately is going to happen is it is definitely going to enter my biliary system, isn't it? So this is your interbiliary canaliculi. Okay, now before going into that, let me explain what all I have drawn here. Okay, so if you look into that, you have something called as your this is your right hepatic duct. Fine, this is your right hepatic duct and this is your left hepatic duct. So your right hepatic duct and left hepatic duct, they join to form your common hepatic duct. Fine, so this is your gallbladder, so this helps for storage of your bile. So what happens, so your common hepatic duct and this your this combines with your your common hepatic duct to form your common bile duct. Fine, so once this common bile duct, it comes and joins, what is this? This is your pancreas. Okay, this is your pancreas. So your common bile duct, once it joins your it joins with your pancreatic duct, and finally they are secreted into your gastrointestinal tract. This is the common biliary pathway. Okay, your interbiliary canaliculi, it joins your left hepatic duct, where it is joined by your right hepatic duct, it forms a common hepatic duct, and joined by your gallbladder, it forms your common bile duct, and with the help of your pancreatic duct, it enters your gastrointestinal tract. Okay, now your conjugated bilirubin, it is going to enter my biliary system. Okay, I am going to draw my conjugated bilirubin in black color. Okay, so just remember the conjugated bilirubin is black. Okay, it has entered my biliary system, so it passes through my biliary system. Fine, and ultimately it is going to get secreted into my gastrointestinal tract. So what happens here? In the gastrointestinal tract, with help of some bacteria, this is going to be converted to what is called as your urobilinogen. Fine, what is this? This is going to be your urobilinogen. Okay, most of the urobilinogen, they pass and they are again converted to what is called as your stercobilinogen or stercobilin, and they are excreted via our feces, and that is why you get your yellowish brown color in our feces. Okay, what happens to some part of the urobilinogen which is not excreted? It enters this pathway. What is this pathway? See, as you can see, it travels from the entro to the hepatic again. So this we call it as enterohepatic circulation. Fine. So some of the urobilinogen, it enters our enterohepatic circulation, it travels and it divides into two. One, it enters our hepatocyte. Fine, where it follows the same pathway and it is stored here. And two is it enters our hepatic sinusoids, and from there it enters the bloodstream and it is carried to our kidney. It is carried to the kidney where it is eliminated, and this gives the characteristic yellow color to the urine. Fine. So this is the normal pathway of bilirubin. So how it is basically formed and how it is usually excreted, and what happens to the stercobilin, what happens to the urobilinogen, and all those stuffs. So in the next part, we shall discuss about all the types of jaundice and what happens in each jaundice. So thank you for watching this video, guys. Hope it was helpful. So share with your friends. Thank you.